Hello friends. Today we'll talk about high voltage testing of electrical equipments. Myself, Chandrasekhar S. Patil, Sharan Institute of Technology, College of Engineering, Yadrao, will discuss about this topic. Importance of testing of high voltage equipments. In modern times, world has seen phenomenal increase in demand for energy, one of which is electrical energy. Transmission at extra high voltages, and the erection of systems which may extend across the continents has become the most urgent problem in near future. The very fast development of systems is followed by the studies of equipment and the service conditions they have to fulfill. These conditions will also determine the values for testing at alternating impulse and DC voltages under specific conditions. Nowadays, in the modern times, where the requirement or the demand for energy is increasing day by day, especially the electrical energy, the transmission and the distribution part is one of the most important area which is carried out at extra high voltages, and the erection of systems which may extend across the continents. So all these, taking all these into considerations, the testing of the transmission accessories or the transmission equipments and the distribution equipments in the power system at high voltage levels has become very critical or become very important. So also we have to understand the conditions or the service conditions of these equipments which they have to fulfill during the operation. They will also determine the testing at alternating impulse and DC voltages. So for specified conditions, we have to know what is the behavior of these equipments at alternating impulse and DC voltages. The problems associated with testing at higher voltages. So what we require for testing at higher voltages is dimension of high voltage laboratories is very huge. So everyone cannot go for high voltage test laboratories, and since the dimensions of these laboratories is very huge and the capital investment is also very large. Characteristics of equipments for such laboratories. Even the equipments which are installed or which are kept in the high voltage laboratories are not general type, but they are of characteristic equipments and they are specific to the high voltage laboratories. Some aspects of the test techniques at extra high voltages. So even the test techniques or the procedure which is followed during the high voltage testing is very important and which is specific to high voltage laboratories, and the figures or the values of test voltages under different conditions are different, and whatever the values we are taking up for the test voltages which will be very typical and which is of very huge magnitude or huge value. Sizes of the test equipments in AC, DC and impulse voltages. Even the size of the equipment is different, and even the equipments are different for AC, DC and impulse voltage testings. Distances between the objects under high voltage during the test period and earth conditions. The distance between the objects under high voltage and under high voltage during the test period between the objects and the earth surroundings is to be maintained, and it should be properly taken into consideration. So one by one we'll understand the power high voltage testing of power system equipments. Types of insulators. Various types of overhead line insulators are pin type, post type, string insulator unit, suspension insulator string and tension insulator. Here in the testing of insulators, we have to note down that for testing of insulator, it is hung by a suspension eye from an earthed metal cross arm. So a cross arm, the insulator is hung from the suspension eye from an earth metal cross arm. Test voltage is applied uh, between the cross arm and the conductor hung vertically from the metal part on the lower side of the insulator unit. Generally, the high voltage is applied at the lower side of the insulator unit, which is hung from the in the upside down condition. Testing of insulators. So different tests carried out on insulator are power frequency tests and impulse tests. So we'll understand the different tests carried out on insulator. 50% dry impulse flash over test. This test is carried out on clean insulator mounted as in normal working conditions. Impulse voltage of 1 by 50 microsecond wave shape and of an amplitude which can cause 50% flashover of insulators is applied. That is, impulses applied, 50% of the impulses should cause flashover. 20 applications of impulse should not damage the insulator. So 1 by 50 microsecond of voltage wave shape is impulse voltage is applied, and generally 20 applications of impulse voltages are carried out and 50% of dry impulse flashover test should take place. Impulse withstands test. Standard impulse of 1 by 50 microsecond wave of specified value under dry conditions with both positive and negative polarities is applied. If 5 consecutive applications do not cause any flashover or puncture, the insulator is deemed to have passed the impulse withstand test. Dry withstand test. Power frequency voltage is applied to the insulator and the voltage is increased to a specified value and maintained for 1 minute. Voltage is increased gradually until flashover takes place. Insulator is flashed over at least 4 more times. Mean of at least 5 consecutive flashover voltages must not be less than the specified in the specification. Wet flashover and wet 1 minute rain test. This test is carried out under artificial rain. It is called wet flashover test. The insulator is subjected to spray of water of following characteristics. Precipitation rate 3 plus or minus 10% millimeters per minute. Direction 45 degree to the vertical. Conductivity of water 100 microsiemens plus or minus 10%. Temperature of water at ambient conditions should be plus 15 degrees centigrade. The insulator with 50% of 1 minute rain test voltage applied to it, then sprayed for 2 minutes. The voltage raised to the 1 minute test voltage is approximately 10 seconds and maintained there for 1 minute. The voltage is then increased gradually till flashover occurs and the insulator is again then flashed at least 4 more times. The time taken to reach flashover voltage being in each case about 10 seconds. The flashover voltage must not be less than the value specified in the specifications. Now we will understand about the temperature cycle test. The insulator is immersed in a hot water bath whose temperature is 70 degrees centigrade, higher than normal water bath for T minutes, capital T minutes. If it is then taken out and immediately immersed in normal water bath for T minutes. After T minutes, the insulator is again immersed in hot water bath for T minutes. The cycle is repeated 3 times and it is expected that the insulator should withstand the test without damage to the insulator or glaze. Here T equal to 15 plus W by 1.36, where W is the weight of the insulator in kilograms. Then electromechanical test. The test is carried out only on suspension or tension type insulator. The insulator is subjected to 2.5 times the specified maximum working tension maintained for 1 minute. Also simultaneously 75% of the dry flash over voltage is applied. The insulator should withstand this test without any damage. Then we have the mechanical test. The mechanical test is bending test applicable to pin type and line post insulators. The insulator is subjected to a load 3 times the specified maximum breaking load for 1 minute. There should be no damage to the insulator, and in case of post insulator, the permanent set must be less than 1%. However, in case of post insulator, the load is then raised to 3 times and there should not be any damage to the insulator and its pin. Then we have the porosity test. The insulator is broken and immersed in a 0.5% alcohol solution of fuchsin under a pressure of 13,800 kilonewtons per meter square for 24 hours. The broken insulator is taken out and further broken. It should not show any sign of impregnation. Next is puncture test. An impulse over voltage is applied between the pin and the lead foil bound over the top and side grooves in case of pin type and post insulator, and between the metal fittings in case of suspension type insulators. The voltage is 1 by 50 microseconds wave with amplitude twice the 50% impulse flashover voltage and negative polarity. 20 such applications are applied. The procedure is repeated for 3.5 times the 50% impulse flashover voltage and continued till the insulator is punctured. The insulator must not puncture if the voltage applied is equal to the one specified in the specifications. Then we have the mechanical routine tests. The string in insulator is suspended vertically or horizontally and a tensile load 20% in excess of the maximum specified working load is applied for 1 minute, and no damage to the string should occur. So these are the different tests carried out on the insulator, and now we'll understand the testing of cables. High voltage power cables have proved very useful in case of HVDC transmission. Underground distribution cables not only give good aesthetic value in metropolitan city, also it provides reliable power supply to the customers. Cable is prepared well for performing various electrical tests. The length of the cable sample varies from 50 centimeters to 10 meters. The tests carried out on cables are bending tests, loading cycle test, thermal stability test, dielectric thermal resistance test, life expectancy test, dielectric power factor test, power frequency voltage withstand test, impulse withstand voltage test, partial discharge test. So one by one we'll understand the tests carried out on cables. Bending tests. Voltage test should be made before and after a bending test. The cable is bent round a cylinder of specified diameter to make one complete turn. It is then unwound and rewound in the opposite direction. The cycle is to be repeated 3 times. If it is able to withstand the bending test, then the sample is or the cable is said to be have passed the test. Loading cycle test. A test loop consisting of cable and its accessories is subjected to 20 load cycles with a minimum conductor temperature 5 degrees centigrade in excess of the design value, and the cable is energized to 1.5 times the working voltage. The cable should not show any sign of damage. Thermal stability test. After test as in carried out in loading cycle test, the cable is energized with a voltage 1.5 times the working voltage for a cable of 132 kilovolt rating, and the loading current is so adjusted that the temperature of the core of the cable is 5 degrees centigrade, higher than the specified permissible temperature. The current should be maintained at this value for 6 hours. Dielectric thermal resistance test. The ratio of the temperature difference between the core and the sheath of the cable and the heat flow from the cables gives the thermal resistance of the sample of the cable. It should be within the limits specified in the specifications. Next, we have the life expectancy test. In order to estimate the life of a cable, an accelerated life test is carried out by subjecting the cable to a voltage stress higher than the normal working stress. High voltage sharing bridge is used to perform the dielectric power factor test on the cable sample. Then we have cables are impulse withstand voltage test. Cables are tested for power frequency, AC and DC voltages. During manufacture, the entire cable is passed through a higher voltage test and the rated voltage to check the continuity of the cable. As a routine, the cable is subjected to a voltage 2.5 times the working voltage for 10 minutes without damaging the insulation of the cable. HVDC of 1.88 times the rated DC voltage of negative polarity for 30 minutes is applied and the cable is said to have withstood the test if no insulation failure takes place. Partial discharge test. Partial discharge measurement of cable is very important as it gives an indication of expected life of the cable and it gives location of fault if any in the cable. When the cable is subjected to high voltage and if there is a void in the cable, the void breaks down and the discharge takes place. As a result, there is sudden dip in voltage in the form of an impulse. This impulse travels along the cable and the duration between the normal pulse and the discharge pulse is measured on the oscilloscope and this distance gives the location of the void from the test of the cable, from the test end of the cable. However, the shape of the pulse gives the nature and the intensity of discharge. So these are some of the tests carried out on cables. So next part we'll understand about testing of bushings. Bushings are an integral part of high voltage machines. Bushing is used to bring high voltage conductors through the grounded tank or body of the electrical equipment without excessive potential gradients between the conductor and the edge of the hole in the body. Bushing extends into the surface of the oil at one end and the other end is carried above the tank to a height sufficient to prevent breakdown due to surface leakage. The tests carried out on bushings are power factor test, in which the bushing is installed as in service or immersed in oil. The high voltage terminal of the bushing is connected to a high voltage terminal of the sharing bridge and the tank or earth portion of the bushing is connected to the detector of the bridge. The capacitance and the power factor of the bushing is measured at different voltages as specified in the relevant specifications and the capacitance and the power factor should be within the range specified. Impulse withstand test. The bushing is subjected to impulse waves of either polarity and magnitude as specified in the standard specifications. 5 consecutive full waves of standard waveform 1 by 50 microseconds are applied and if 2 of them cause flashover, the bushing is said to be defective. If only one flashover occurs, then 10 additional applications are made. If no flashover occurs, bushing is said to have passed the test. Next we have the chopped wave and switching surge test. Chopped wave and switching surge of appropriate duration tests are carried out on a high voltage bushings. The procedure is identical in case of impulse withstand test. Partial discharge test. In order to determine whether there is deterioration or not of the insulation used in the bushing, this test is carried out. Okay, and we have the visible discharge test at power frequency. The test is carried out to ascertain whether the given bushing will give rise to the ratio reference or not during operation. The test is carried out in dark room. The voltage as specified is applied to the bushing as per IS 2099. No discharge other than that from the grading rings or arcing horns should be visible. We have power frequency flashover or puncture test. The bushing is either immersed fully in oil or is installed as in service condition. This test is carried out to ascertain that the internal breakdown strength of the bushing is 15% more than the power frequency momentary drive withstand test value. So these are the tests. This is what all about the tests carried out on insulators, cables and bushings. So in the next session we will talk about testing carried out on power capacitors and power transformers. Thank you.